Can you see the screen?
Sir?
You can see the board, right? Probability.
Yeah, I can see the board, sir.
Yeah. So we'll start with probability today.
Okay, sir.
Okay. Um, so certain things you learned already, like in earlier classes. There's something called a sample space, then outcome of an experiment, all possible outcomes of an experiment, and then event of a sample space. First thing, what is a sample space and what is an experiment? Experiment is something like examples are we toss a coin. For example, we throw or toss a coin. You can toss it for 1 time or 2 times or 3 times like that, or throw a die or pair of dice. So all these we can call them statistical experiments. These are not physics or chemistry experiments. These are called statistical experiments. So under statistical experiment, for example, when you toss a coin, so all the possible outcomes are, the outcome is, in case of tossing a coin, outcome can be either head or tail. It can't be both. So this is one time I throw a coin, I can get either head or tail. So the sample space usually represented as a set with this bracket H, comma, T. This is the sample space for this. Outcomes, when we say, it can be either heads or tails. For example, I toss a coin 2 times tossing. Then we can consider both times you can get head and head, first time and second time, or both times you can get tail and tail, or first time head, second time tail, or first time tail, second time head. So many possibilities are there. So all possibilities put together is a sample space. This is a sample space.
Sir.
Out of that, each one is outcome. This is one outcome, this is another outcome, and this is another outcome, like that. Each are outcomes. I wrote it here. Out of the total outcomes, if you take favorable outcomes, then that is called an event. So favorable, non-favorable depends on how we start looking at the sample space. For example, if I say I tossed the coin tossed 2 times, twice, and I'm interested in both same face or both same type. That means either HH or TT. So this is what I called as my event, because this is a favorable thing. Even though I got 4 outcomes, so the event is both coming as the same thing. So the event space becomes either HH, TT. This is an event. So now, if I need to find out what is the probability of getting same type when we toss the coin 2 times. So when we ask like this, the way we have the probability defined is number of favorable outcomes or the event, how many events are there? Favorable outcomes divided by total possibilities, total number of possibilities. This is nothing but the sample space. This is nothing but the event space. So in my event space, I got 2 only. In the sample space, I got 4. So the probability is half. Any questions on this?
No, sir.
No. Okay. So let's suppose we have a throwing a dice now. Let's consider we have another experiment. We are considering this experiment as a 6-face die. A 6-face die is thrown once. What is the probability? Find probability of getting first one, 5 on the face. Second one, an even number. Third one, something greater than 3. So we have 3 different events. So in order to solve this question, we need to first write down sample space. So the sample space, you can draw even diagrammatically also. So the sample space will be, it can be either face 1, 2, 3, 4, 5, or 6. Any of these 6 can come. So the number, how many are there in the sample space? It is 6. Let's put the event space now. For the first one, the event space is 5. That means only 5. We are interested in 5, only 5. Therefore, n of e, that means how many elements are there in this event space, is 1 only. So the probability of getting 5 equals n of e divided by n of s. N means number. So this becomes 1 by 6. So now the second question is getting an even number space. So now S is no change. S sample space is same thing. E will be even numbers 2, 4, 6. So n of E is 3. Therefore, probability of getting even equal to n of E divided by S of E. Sorry, n of E divided by n of S. So you'll get 3 by 6, which is 1 by 2. This is 1 by 2. So third one, we said a number greater than 3. So a number greater than 3, E will be 4, 5, 6. So the probability would be greater than 3 equals to n of E divided by n of S, which is 3 divided by 6. Again 1 by 2. So far you understood, right? There is no issue with this one. So the next topic in this is how do we draw a diagram for the outcomes. Okay, so that's what I'll be explaining in this next one. So there are 2 types of representations. To arrive at the sample space, to get sample space, we use something called a ladder diagram, or the second one we call this a grid. So especially when you are throwing something 2 times, like a 2 times coin or 2 times dice thrown, like that, you will use the grid. What's a ladder diagram? Ladder diagram is, for example, I throw a coin 3 times and I want to list down all possibilities. So one way to list down is, like we'll say H, 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 and then T, 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 and putting all the things like this. The other way is, so first experiment, there are 2 possibilities. This is what the ladder diagram is. It can be heads or it can be tails. This is the first experiment, first throw. Then here you are doing second throw. Again, it can be either heads or tails. This is the second possibility. If it is a tail, also you can have either heads or tails. Then you do the third level. Another heads, another tails. Or it can be another heads or another tails. So this can be heads or tails. This can be heads or tails. So now, how do we get like this set from here? It's easy. So first time H, second time H, third time H. So you'll have H, H, H. That's one. HHT, second one. Then HTH. Then you have HTT. Then you start with THH, that is this, THH. The next one will be THT. Then you will have TTH. And the last one is TTT. So if you see, there are 8 are there. So why can't I do this way, writing down like this? Why should I go this way? Here, every time you need to remember, like, how many are there? 6 are there, 7 are there, another 2 are there. So what I have written, what I have not written, like that. But when you go in a structured way like this, in the ladder diagram, you will get all possibilities laid down. So this is what the total sample space. So to get a sample space, we use these tools called ladder diagram. We can also use grid, especially only when you are using 2 times. So let's see how I use the grid. For example, 2 dice are thrown, dice 1 and dice 2. They are thrown. So I want to find out the sample space. So the sample space can be 1, this is for this side possibilities for dice 1, this side possibilities for dice 2. So it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, or it can be 6. It can be 2, 3, 4, 5, or 6. So now we are making a grid. So this is the 4th one, this is the 5th one, and this is the 6th one. So similarly, you will write 1, 2, 3, 4, 5, and 6. So how many are there? 6 multiplied by 6. You got 36 possibilities. Enough sample space will be 36. But how do I write sample space? Simple. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, like that. So 1, 5, and then the next one is 1, 6, 1, 6. Then comes 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, like that. So you write for the last one also 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So this is how you get a sample space. So you may ask, should I write this or should I draw a diagram? That should be okay. Even the diagram you draw it is fine to have a sample space. So we have now talked about 2 ways of getting a sample space simplified. One is through ladder diagram, other one is a grid method. So these 2 diagrams are important for one reason. Okay, I will take this example of whatever I have done for throwing a coin 3 times. Now I am starting to explain what is the conditional probability. That is, today's topic is conditional probability. Conditional probability is trying to find out. Unconditional probability is you are looking at the total sample space. Total sample space. Under that, you are actually looking at one event. That is unconditional probability. This is unconditional probability. So in a conditional probability, out of the total sample space, you say that something has already occurred. This has occurred already. Some event has already occurred. If we know that this has occurred, what is the probability of some event happening? So your sample space has become this now. So this is the conditional probability. Finding out when the sample space itself is restricted. How the question will be? Question will be like this. A coin is tossed 3 times. I know that the last time, the third time, I got tails. I know that guaranteed. The last attempt was third time I saw it is tails. What is the probability that first time also I got tails? So now the sample space is not the entire thing. I'm saying only this or this or this or this. So from here, I have to trace backward so that I get the first one as a T. So this is not the possibility. So this is also not the possibility. So this is possibility. The first can be. So another one, this can be a possibility. So you got 1, 2, 3. Only 1, 2, 3 are possible out of the 4. So the answer will be 3 out of 4. This is the probability. So how the question will be like, what is the probability? Find probability of first time tails given, this is the keyword, they will ask in the question, given that third throw gave tails. Question will be like this. It's a famous 1 mark or 2 mark question. This exercise, whatever is the first exercise, definitely you will have a 1 mark or a 2 mark question. So now this is the theory what I explained. So if we have to do what is the working mechanism or working procedure. So working procedure is generally explained with respect to the Venn diagram. Venn diagram approach actually, not necessarily Venn diagram. For example, you have a set A and you have a set B. So in set, for example, you have written so many are there. N of A means how many are there in A? How many in A? N of B means how many in B? This one is nothing but A intersection B. And we write that as N of A intersection B. How many? So the formula now is, this is the one we'll be talking about. Probability of event A occurring given that B has already occurred. So we write as P, we read it as P of A given B. This is how we read it. Okay, but that's the meaning of. What's the probability of A occurring given that B has already occurred? The formula is probability of A given B equal to probability of A intersection B divided by probability of B. This is the formula. It can be written as probability of B given A, we just change them. It is similar, probability of B intersection A divided by probability of A. So when we draw like this Venn diagram, if we know what is the intersection probability and the individual probabilities, then we will be able to calculate this conditional probability. So this is how the working is done. So now I am turning to the first exercise, and I will, before exercise there is some definition is there. I will go to that definition page and explain the definition. I'll write it and then we'll go to the exercise because definitions also come as a 1 mark question. So first definition is nothing but this formula. So what is given in the textbook is instead of A and B, the definition 1, that's the definition of conditional probability is if E and F are two events associated with same sample space of a random experiment, if E and F are two events associated with these definitions, you won't be asked to write the entire definition, but they will just give you a missing, something will be missing, you'll have to fill it up. They'll give the entire text and then something you need to fill it up. Associated with the same sample space of a random experiment the conditional probability of the event A, the conditional probability of event E, given that F has occurred, is given by P E of F, E by F like this, equal to P E intersection F divided by probability of F. So this is the definition. Probability of F cannot be equal to 0 because I am using that as a denominator. So what are the properties of the probability? Properties of the conditional probability. Conditional probability. Again, these are all 1 mark questions. I am covering theory means it can be 1 mark question. The first property is probability of S. Probability of sample space. S means sample space. Given that F has already occurred is nothing but probability of F divided by F, which is equal to 1. What does it mean? Let's suppose you got the sample space. This is the entire sample space. F is a part of that sample space. So what this means is we are trying to find out what is the probability of something happening in sample space. We already know that F has occurred because F is already part of S. That's why we write probability F over F, that's equal to 1. It is, the probability is guaranteed because something out of S is already occurred. So how do we prove that? Proof part, we'll take this as probability S by S equal to probability of S intersection F divided by probability of F. Now you see what is common to both S and F. It is F only. That's why it is probability of F divided by probability of F. That's equal to 1. This is what the proof for that. So the second property, if A and B are two events of a sample space S and F is an event of F such that probability of F is not equal to 0, this is the second one is probability of A union B given F equal to probability of A given F plus probability of B given F minus probability of A intersection B given F. So how do we prove that? So what he is trying to say here is, let's suppose you got an event A and you got event B. This is A intersection B. What is A union B? This, this, and this. So he is asking, what is the probability that something, either A or A intersection B or B, has happened, provided F has already occurred? So, how do we say that all this F may be, for example, something like this, maybe F. All this can be F. So, this is what is the question. So, in this, we use the first concept saying A union B is nothing but A plus B. You are adding these two. When you add those two, this is added 2 times. That's why we subtract that 1 time. So we do this. Then what we do, what is the probability of A union B? We take that particular thing. So if this is only to remember. Otherwise, actual formula is probability of A union B, given F equal to, our formula is what? Probability of A union B intersection with F divided by probability of F. This is by definition because you need to use the intersection. So when I use that intersection, you have to distribute this symbol of F with the both. How do we distribute that? Probability of A intersection F. That means what is the combination between A and F? Take that union comes in between and probability of B intersection F divided by probability of F. This is the only step you need to remember. Then you will be using this completely with the formula of what we talked about. How do we do A union B intersection B? So you have got this union here coming up. Okay. Either you can write with this P, also you can write without the P also, meaning one step backward. What it means is I can just take this as probability of this and this because you just applied the formula for this only. So now I am considering this entire thing as one P, this entire thing is a Q. So I already wrote P union Q is like this. So I write that as probability of this union this is equal to, you will have just A intersection F, okay, plus you will have B intersection F minus P intersection Q, which is nothing but common for both of them is A intersection B intersection F. This is how we write this top part. Divided by probability of F. So now divide each one, you will get probability of A intersection F divided by probability of F plus probability of B intersection F divided by probability of F minus probability of A intersection B intersection F divided by probability of F. So the first part is nothing but probability A given F. The second part, probability B given F. Then the last one is minus probability of A intersection B given F. So that's how the proof is done. And subset of this is, the corollary for this is, if, for example, A and B, if A and B are disjoint, remember disjoint. If they are disjoint, what happens is A intersection B is a null set. So it will be 0. So then this becomes probability of A union B given F equal to, this becomes 0. You will have the first one, A by F plus probability of B by F. That's it. So that is the subcase. Then we go to the the property 3. So we'll write property 3. The third property is probability of having E dash given F equal to E dash is nothing but complement 1 minus probability of E given F. So, for example, you have a sample space like this. I draw a sample space. This is the event E. What is the other part? Whatever S minus E. So this is called E dash. We also call this is S minus E. So entire sample space minus the event space E. So we use this diagram to draw the proof for this. Probability of E dash F given F equal to probability E dash I replace with S minus E given F. So you can write that as S minus E, or you can write as E union E dash. So probability of S, if I write like this, then I must be using a different formula. This is possible. But how do I write E dash? So probability of S given F equal to 1. We already know that. So what is S? It is nothing but E union E dash. See, you add both the things, you will get S. That's equal to 1. So this formula we already have done. That means there is no, these two are disjoint. Therefore, this is probability of E given F plus probability of E dash given F, just the property 2. This is by property 2. So, and whatever is the minus probability of E intersection E dash given F equal to 1. This is 0. So this part is gone, 0. So you will get probability of E given F plus probability of E dash given F equal to 1. And therefore, probability of E dash given F, that is this, equal to 1 minus probability of E given F. Approach. So now the question is, will I get any of these properties you have done in the exam? Okay. For this year, that means when you are writing, I doubt they will give, they have not given this so far in the final examinations. Any of these properties is not given as a proof, but as a 1 mark question, like this, whatever I picked, this can be a 1 mark question. This one can be a 1 mark question. That can be given, and it was given. Any questions?
Yes, sir.
Sham, any questions? No, right?
No, sir. No, sir.
No questions. Okay. So now the next page, the first exercise, that's exercise 13.1. Exercise 13.1. And it's a page 538. The first question is given probability, question number 1, given E and F for events such that probability of E equal to 0.6, probability of F equal to 0.3, and probability of E intersection F equals 0.2. Find probability of E given F and probability of F given E. So the solution is, we know the formula. Probability of E given F is nothing but probability of E intersection F divided by probability of F. So this is probability of E intersection F, which is 0.2 divided by probability of F is 0.3. So you got 2 by 3. So the next one, probability of F given E equal to probability of F intersection E divided by probability of E. So probability of F intersection or E intersection F both same. So you'll have 0.2 divided by 0.6, which is 2 by 6. So you have 1 by 3. So 1 by 3 is the answer for. So first question is done. Second question. Compute probability of A given B is how much? Probability of B is given as 0.5 and probability of A intersection B is given as 0.32. So we use the same formula. Probability of A given B equals probability of A intersection B divided by probability of B. So that's equal to 0.32 divided by probability of B is 0.5. So that is 32 divided by 50. That is nothing but 64 divided by 100. So it's 0.64. That's the answer. So I have question number 3. Let me see whether you will help me with one part. Probability of A is given as 0.8. Probability of B is given as 0.5. Probability of B given A equal to 0.4. First, he is asking us to find out what is probability of A intersection B.
It is P into 0.8 into 0.5.
0. This into this or this into this? First one, this is the first one or second one? Which one is should I use?
First one.
First one. So 0.4 multiplied by 0.5, you will get 20, so it's a 0.2. Now let's look at the formula. So we have to write the formula for this, right? Probability of P given A equal to probability of B intersection A divided by probability of A. So this we don't know, we'll say X divided by probability of A is 0.8. So probability of this is, so other two we have to multiply. So 0.4 equal to X divided by 0.8. Therefore X is equal to 0.32. Okay,
Yes, sir.
that's the one. So the next question is, we need to find out probability of A given B. So use the formula again. Probability of A intersection B divided by probability of B. Because B is at the bottom, here also should be bottom. A intersection B, just now we found out, that's 0.32. Divided by probability of B is
0.5.
0.5. So this we have done, we already did 0.64. Last time we did that. Then third one, probability of A union B. So we use that formula. What is the probability of A union B? This is nothing but probability of A plus probability of B minus probability of A intersection B. So what's the probability of A is 0.8. Probability of B is 0.5 minus probability of A intersection B is 0.32. So it's 0.18, 0.8 plus 0.18. So it's 0.98. So that's the answer for that. Fourth question. You may have to do fully. I'll write the question, you may have to do this question. Evaluate A union B. No, probability of A union B. Probability of A union B. If 2 times probability A equal to probability B equal to 5 by 13 and probability of A given B, probability of A given B equals 2 by 5. So you can tell the steps, I can write it to save time.
2PA is equal to 2B. Or should I write it again? Given.
Yeah. So this is the first step you are saying, right? So therefore, probability of A equal to 5 by 26. Probability of B equal to 5 by 13. So I written that for you.
So PA is going to be 15 by 13 into 2, right?
P of A.
Yes, sir.
No.
Sir.
See, you are equating this to this. 2P of A is 5 by 13.
Yes, sir.
So 1P of A will be, this 2 will come down 5 by 26.
Yes, sir. 5 by 13 into 2, right?
Correct. 13 into 2. Yes. 5 by 26. Correct. 13 into 2. So you got P of A, P of B. And you also have P of A given B.
Yes, sir.
So first thing what you need to do is, you have to use the same formula what I have written here, which is
P by A.
the last one, this one. So this formula you have to write. And in that, we don't know this. We have to get this, A intersection B. So I will guide you from this. This is where we have this. What we need to find out is this. But for this, you need A intersection B is required. So let's work on A intersection B. How do we get A intersection B? So use this in the formula. Probability of A given B equal to probability of A intersection B divided by probability of B. So this is X, we don't know, divided by probability of B is 5 by 13. Probability of A given B is 2 by 5. So we write 2 by 5 equal to X divided by 5 by 13. Do the cross multiplication. 2 by 5 into 5 by 13 equal to X. So X equal to 2 by 13. What is this X? Probability of A intersection B. Now we are using the formula probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So probability of A, we got that 5 by 26. Probability of B, 5 by 13. And probability of A intersection B is 2 by 13. So doing this fractions, LCM is 26. 5 plus 10 minus 4. So you got 11 divided by 26. Understood?
Yes, sir.
Okay. So the fifth question. If you want, you can do in a notebook. I will write down the question. Fifth question. P of A is 6 by 11. P of B is 5 by 11. Probability of B is 5 by 11. P of A union B equal to 7 by 11. Find first one, P of A intersection B. The second one, probability A given B. Third one, probability P given A. Try and you can send me the WhatsApp. Okay. If you want any of the previous thing, I can show you on the board. Shall I keep the top one, this one, or no need? Or tell me whichever way you want me to show, I'll show the screen, corresponding screen.
Okay, sir. Sir, is the first one 4 by 11?
Correct. Good. So this is what you do. 6 by 11 plus 5 by 11 minus 7 by 11, 4 by 11. Good. Correct answer.
I have to find for all the three, sir. 4, 3.
Yeah, 3. Why don't you do second and third also?
Okay, sir. Sir, PA by B is equal to PA intersection B by PB.
Correct. Good.
So is 4 by 5 the answer?
Correct.
Next one is 2 by 3, sir.
Good. All answers correct. Okay. So
Okay, sir.
yeah, I think we are done. First questions, 5 questions are done. Then you have next question 6 to 9 are one type. They're all to be done together. Okay, so it's no point I stop at the 6th question. Rather, I stop here. But I'll ask you, have you understood everything? Anything you want me to revise or anything from here?
No, sir, understood, sir.
Yeah, this is actually simplest. And once whatever you have done so far, will definitely you'll be able to get one or two or more 3 marks. Okay, you will be able to
Okay,
get
sir.
maximum 3 marks, minimum 1 mark in exam, guaranteed.
Okay, sir.
Okay. So how was you? Are you going offline classes? Going to the college?
No, sir. I have exams from next week onwards. Not next week, this Friday onwards.
This Friday onwards exams, sir.
Sir, I have to go there and do.
What? Which topics? Maths? Which topics? Physics? What topics?
They're saying all the topics this time.
How come? Did they complete syllabus?
No, not yet.
How then? How can there be all topics by today is Monday and
No,
by
no, sir.
Friday?
Sir, they're simply putting this exam for no reason. So
Oh,
I don't know if I'm going. Not many people are going
uh-huh.
because it's very dangerous.
No, risky because still the things are not stabilized. But
Sir,
they're just
this
calling.
time when I went,
Hmm.
this time when I went for the lab, the teachers are also not wearing masks. So
She's also not wearing mask. Hmm. No, these two
yes,
are
sir.
important.